Hi, how's it going? It's Rob again, still talking about comms. Surprised? Don't be. So, I don't have my whiteboard today. I decided that the whiteboard may have been a little bit played out, and you guys probably wanted to see some hardware. And no, I'm off the road for a little bit and at my house, so I wanted to pull out some hardware and put some skin on the concepts that we've been talking about. So, I didn't really have a script for today. Wait, sound like he never has a script. Yeah, I don't. I just kind of want to talk about what we have in an intercom system. What's in the truck that you might not be seeing as a user, or just some ideas that may not be apparent to you. That's what this whole thing is about, right? So I'm an RTS guy. I'm pretty deep into RTS. So these are the examples that I have. They are RTS two wire or RTS uh, KP or Matrix or whatever, but the concepts are all the same for ClearCom or for Riedel or for a myriad of the others. So I just wanted to start and wire up a simple representative two-channel station or two-channel user comms. So I don't want to take anything for granted here. So guys, there's some male XLRs here in the back of this. Ooh, wait, I'll start here. This is a PS15, a power supply 15. This is a single channel power supply. It supplies power for one channel of belt packs. And I have another one over here that's a PS20. It supplies power for two channels worth of belt packs. And the powered channels that I'm talking about, we can get into later about why you would need more than one powered channel, but it kind of comes into creating more groups of party lines. It would be involving a SAP or a source assign panel where you might be able to mix a type of or a group of belt packs for cameras over program, and then the next group of belt packs would be stage over program. And I mean that would be like cameras talking here and listening to program here, or cameras over stage, and then this one is cameras over stats. So you can build different belt pack combinations with multiple powered channels. But this being an RTS system, we can have power on channel 1 and still have the ability to talk and listen on this second channel over here. So I'm going to construct a two-channel intercom with two discrete talk paths to two belt packs to start with. I've got an XLR. There's male powered outlets here, and I'm going to wire this up a couple of different ways, and these are all going to be exactly equal. I'm coming out of the power supply once. I'm going power on pins. Intercom, generally, the power is, or the pins are run to the field. And I'm going to go into the female side of this belt pack and do the same over here. And this simple representation of an intercom is wired. We are talking and listening on two different channels. Now, I'm going to wire this again in a different way, but it's going to give us the exact same functionality, I think. All right, so we can daisy chain out of this belt pack, and we can go two packs this way. Oops, two packs this way. This is giving us the same channel 1 over channel 2. All right, I'm even going to go a little bit further and get wacky and put in a comm splitter. A comm splitter. These are for sale on eBay and other places where they make these fancy dancy comm splitters. Well, I'm going to use an XLR Y cable for my comm splitter. Mine happens to be female in and male out, and I am going to wire my two-channel intercom. Watch me go, folks. Oops. This Y cable coming once out of the power supply, going one into a belt pack, and another time into a belt pack. Did you know that? Once out of the power supply and one into each belt pack on a straight, normally wired Y cable. I'm going to let that sink in for a second. Yes, this works. Yes, you'll be able to hear everything on all the packs. This is just a loop. And the wiring doesn't have to be in a loop. It could be in a wire. You could even do something like, I don't know, one normally wired belt pack. This is all just topology of this exact same thing. You could loop out of this belt pack and then go 2 different directions at this point. This is all parallel wiring. It is all accomplishing the exact same thing. But wait, there's more. Using this knowledge, you can create your own comm splitter. I just did one right here. But I pulled one out of a kit that I had built and have disassembled. And this is nothing more than a, 8-position D-hole 1RU panel. And on the back, I have just done straight parallel wiring. I can't get close enough to show this to you, but this is red in, red out, black in, black out, unshielded in and out. So all the pin 1s are tied together, all the pin 2s are tied together, and all the pin 3s are tied together. And I feed it 1 time, and you can go 4 times out. But wait, there's more. You could even come out of this 4-way Y cable with another Y cable. What's going on? With another Y cable, and you could put that into a string of belt packs as well. So, have I made my point that once you get into the 2-wire world, you can just split it however you want? Well, good. I'm glad you understand that now. So, I'm going to take our 2-wire belt pack system that you completely understand, and I'm going to tie it to some larger things. All right? So, if this is a self-contained intercom system, if all of your talkers and listeners are belt packs, then you're done. All you need is a power supply and however many belt packs, and XLR cabling, and if you want, XLR splitters or some kind of mechanism to split the signal. Burp. Good informational video, right? But wait, there's more. So I keep talking about tying these belt pack systems into larger frames, larger comms. And I don't know if people don't believe me or don't get it or don't think I'm talking to them, but this is really a big deal. And in the bigger systems, there is a brain sitting somewhere. Even if you're on a belt pack and you're on the outside of a television truck, I promise you, not everybody in that truck is on a belt pack. They're on a larger system, and this is an extension of that system. So I'm going to simplify my desk a little bit and use this power supply, which is it's the same thing, but it doesn't have this janky cord on it. So I'm going to use this to represent the 2-wire system that the stage manager or the timeout coordinator would be wearing on the outside of the truck. And now we're going to use this to attach to something else. And I have 2 devices here. This is an SSA 424. This is an SSA 324. And they do the same thing. This is a more analog model, and it has some manual adjustments. And this is a bit more automated model and has self-adjusting circuits inside of it. So 324, 424. I'm going to put this one aside because this one's just a little bit simpler to look at on the back. Now, all of the connections are needed here is an XLR, right? So I'm going to come out of here, and this is going to be the representation of connecting to the larger system. Well, look at the back. This is already ready to connect 1 time to this system. Okay? And this is a 4-wire to 2-wire converter. 2-wire going out to all of the belt packs, and then 4-wire going back to the matrix. And so I'm going to put this as the intermediary to, you thought I would never get here. This is a digital matrix intercom. This is the Cronus frame. It's capable of 32 talk destinations, and it is 2 RUs tall. And on the back here, this frame has been half populated. There are 16 talk listen destinations capable in this frame. All right. Every one of these is terminated on an RJ12 connector. RJ12 being 6 connectors wide phone jack. They look like an oversized phone jack. Focusing isn't going to focus, but it's a 6 conductor phone jack. This is the native connector type for this intercom frame, and there are others that are native, but this is the one that this frame has been outfitted with. So I'm going to connect this 2-wire section of the intercom to this intercom frame. Are you ready? I'm going to go in port 1. Are you ready? Oh, it's been done. Port 1 of this intercom is now connected all the way to this belt pack. Okay, you're right. I was missing one XLR cable. If I was to press down on a user interface on this intercom, it would go through this power supply, or it would put the audio on the pairs. This audio or power supply puts the power on, and I now have a fully functioning belt pack on a Cronus intercom system. What are the people going to touch and talk to? Well, I brought out a KP32. This is the hallmark of a user interface for a matrix intercom. Each switch is programmable with a talk and talk and a listen opportunity. And so this connects to this frame, one user, one opportunity, one control service. Uh-oh, I don't have 2 of the cables. So excuse me while I remove this. This audio and data cable is also the native connector, one of them, on this KP panel. So now I've connected a KP32 to the intercom frame, and I have given a user a place to talk and to listen. The best headset in the world, RTS PH88, 5-pen. This is the hallmark standard intercom headset for this KP panel, and this, my friends, represents the entirety of an intercom system at the highest level. This is honestly all it takes. A headset, a 6 conductor telephone cable on a 2-wire to 4-wire, a 2-wire power supply, and a belt pack. Oh yeah, and the digital matrix intercom. So I just wanted to put some skin onto the bones of the theory that we've been talking about and let you see the entirety representation of an intercom system made by RTS, a frame, a user, and then, and you may have, well, everybody in the truck would have one of these. Or everybody in the field would have one of these. And so this is how this system is built. So hope this has been helpful.